Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. In this video lecture, we will study Bessel formula, the fourth central difference formula. Earlier we have studied Gauss forward interpolation formula, Gauss backward interpolation formula and Stirling formula. So Bessel formula is another central difference formula. And what is central difference formula? Is used to interpolate the value of the function when the value which is to be interpolated falls near the center of the given table. So that is the central difference formula. Now we will study what is Bessel formula. So for the Bessel formula, it is the mean of Gauss forward interpolation formula and Gauss backward interpolation formula after shifting origin to 1. Fine. So that is the mean of Gauss forward interpolation, Gauss backward interpolation after shifting origin to 1. Now we will write the Gauss forward interpolation and Gauss backward interpolation, then we will shift the origin to 1 in Gauss backward interpolation formula and then take the mean. So how do you write Gauss forward and Gauss backward interpolation formula? Is for that you need to make the table. Say this is y naught, this will go up, this will go down, and this will be delta y, this will be delta y. Fine. When you go up, energy is required, this is -1. When you go down, no energy is required, so this will be 0. So this and this will be delta square y. When you go down, no energy is required, it is -1, so here will be -1. When you go up, energy is required, this is -1. So now this will go and this over there. So this will be delta cube y, delta cube y. This when you will go up, it will be -2. When you go down, it will be -1. So this will be, and here will be delta 4 y. When you go up, it will be -2. When you go down, so similarly you go on something like that. And for coefficient, you know you will write u1 u. Now increase u plus 1, write it 2 times u plus 1, and now you will let us say if here is delta 5 y, delta 5 y, go up -3, go down -2. So here will be u plus 2. Fine. And here 1 u, and after u, here you have written 2u, here after u you will write u plus 1. Now write u plus 1 2 times, u plus 1. Now increase it by 1, u plus 2, increase it by write it same at least 2 times. In the next you will write u plus 3, increase it. Similarly you have written here 2 times u plus 1, and then you increase it by 1. Now write here subscript 1, subscript 2, subscript 3, subscript 4, subscript 5, subscript 1, 2, 3, subscript 4, subscript 5, and something like it will go on. Fine. Coefficient will go on and this table will go on. Draw the center line. This is the horizontal line drawn in the center. Fine. Now the coefficients along this line, and below will give the Gauss forward interpolation formula, and along this line and above will give the Gauss backward interpolation formula. So Gauss forward interpolation formula is given by please write, this will be yx is equal to y naught plus u1 into u1 u subscript 1 delta y naught plus u subscript 2 delta square y minus 1 plus u plus 1 subscript 3 delta cube y minus 1 plus u plus 1 subscript 4 delta 4 y minus 2 and so on. This is Gauss forward interpolation formula. Now you will write the Gauss backward interpolation formula. From here it will be, write Gauss backward interpolation formula. Fine. Is given by, is given here, also given by. So please write yx is equal to y naught into 1, this will be y naught plus u subscript 1 delta y minus 1 plus u plus 1 subscript 2 u plus 1 subscript 2 delta square y minus 1 plus u plus 1 subscript 3 delta cube y minus 2 delta cube y minus 2 plus u plus 2 subscript 4 delta 4 y minus 2 and so on. Let us name this equation as equation number 1 and name this equation as equation number 2. Now next what we'll do, we will be shifting the origin in equation number 2 by 1. Okay, and when you shift the origin, let us take, we have a coordinate system xy and we shift the origin of that coordinate system to hk, and x dash y dash is the new coordinate system. Then in that case what we do x is equal to x dash plus h, so that when you replace here h, this x dash will be new origin. Okay, fine. So here this means that x dash is equal to x minus h. Similarly y dash will be y minus k. When you will shift the origin to 1, then this u is equal to u dash plus 1. So this u dash will be u minus 1. So simply replace u by u minus 1. Fine. And this index, this subscript of y is shifted in the forward direction by 1. Here it will be shifted, and this u1 will not be changed because u1 here, simply showing that this is u by 1 factorial, this u plus 1 2 factorial is equal to u plus 1 u by 2 factorial. So shifting of the origin will not make any difference to the, because it is only signifying that it is product of two terms. So the shifting of the origin will not have any effect upon this one, but and this will shift in the forward direction. Instead of -1 it will be 0, instead of -2 it will be -1, and u will be replaced with u minus 1. So I am going to make these changes over here. So and remove it. So shifting the origin, in Gauss backward formula to 1 in equation 2. What we'll get? We'll be getting right over here yx is equal to y1. Find u minus 1 term below term. Make it sure term below term. u1 will remain, the index will remain the same. Delta, this will become y naught plus this will be u 2 delta square y naught plus u3 delta cube y minus 1 plus u plus 1 4, this will be delta 4 y minus 1. Fine, plus so on. Done, and you are going to name this equation as equation number 3. Now taking mean of equation 1 and 3, we get, what will get? Yx plus yx by 2. Now you will try to write term below the term, y naught plus y1 and divided by 2 plus this and this. Delta y naught will be common, so inside will be u1 plus u minus 1 subscript 1 divided by 2 delta y naught plus u2 will be common, delta square y naught plus delta square y minus 1 divided by 2. Fine, and here delta cube y minus 1 will be common, so it will be u plus 1 subscript 3 plus u3, it will be delta cube y minus 1 and this will be divided by 2. Fine, so I am going to rub this one. Here u plus 1 subscript 4 will be common, so this will be u plus 1 subscript 4 multiplied by, it will be delta 4 y subscript minus 2 plus delta 4 y minus 1 and it is divided by 2, and it will go on something like that. Fine, so this is further equal to y naught plus y1 by 2 plus, now I will be solving this term and writing it over here directly. u1 you know is, write it u minus 1 because u1 is u by 1 factorial and u minus 1 subscript 1 is u minus 1. So I have written something like that, divided by 2 delta y naught plus u2 is, you know, u minus 1 divided by 2 factorial delta square y naught plus delta square y minus 1 by 2. Fine, plus now we solve this one. What it will be? It will be, I am going to solve it over here. u plus 1 subscript 3 plus u3 is equal to u plus 1 decrease by 1 u minus 1 by 3 factorial. Fine. Plus u3 will be u minus 1 u minus 2 by 3 factorial. This is equal to u minus 1 by 3 factorial is equal to u plus 1 plus u minus 2. Fine. So this will be u minus 1 2u minus 1. This will 2u minus 1 by 3 factorial. So I am going to put it over here. u minus 1 2u minus 1 by 2 into 3 factorial. Fine. Delta cube y minus 1, and u plus 1 you know is u. It's u plus 1 u minus 1 u minus 2 divided by 4 factorial into delta 4 y minus 1 I am writing first, delta 4 y minus 2 divided by 2, and this will go on something like that. So I am going to rub this one. Now this is 2u minus 1, so this can be written as y0 plus y1 by 2 plus this will be u minus 1 by 2 delta y0 plus it will be u minus 1 by 2 factorial. You can write delta square y0 plus delta square y minus 1 by 2. Fine. Plus 2 will divide u minus 1 by 2, so it will come in between u and u minus 1. So u minus 1 by 2 u minus 1. Fine. Divided by 3 factorial. Delta cube y minus 1 plus u plus 1 u minus 1 u minus 2 divided by 4 factorial into delta 4 y minus 2 plus delta 4, it's delta 4 y minus 1 plus delta 4 y minus 2 divided by 2 up to so on. This is yx, because 2yx by 2 will be yx. So this is the Bessel formula, and in compact form if you want to write it, you can write it something like y0 plus y1 by 2 plus u minus 1 by 2 delta y0 plus u 2 delta square y0 plus delta square y minus 1 by 2. Fine. Plus u minus 1 by 2 u minus 1 divided by 3 factorial delta cube y minus 1. Fine. And this can be written as u plus 1 subscript 4 and into this one delta 4 y minus 1 plus delta 4 y minus 2 divided by 2 plus up to so on. So this is the compact form of Bessel formula, where we have written this quantity in subscript notation. So which is the required Bessel's formula. Okay, so this we have derived, and this formula is a central difference formula used when u is between 1 by 2 and minus 1 by 2. And of course when u will become 1 by 2, this formula is more suitable, because in this case odd differences, if u is equal to 1 by 2, then odd differences, this will become 0, this will become 0, odd differences are 0, and then this formula is more suitable. So this formula used when u lies between minus 1 by 2 and 1 by 2, and more suitable when u is equal to 1 by 2. So now we will learn how to write it from the table directly when we have to use it in the numerical. So how to write this formula. So now we will learn how to write Bessel formula from table. So we'll form the table. This is y naught, and since origin was shifted, so I will also write y1. So now this will converge something like this one. Fine, and this will be delta y. Now this will go something like that. Fine, write delta square y, delta square y. Fine, this will go something like this one. This will be delta cube y. This will go something delta 4 y. This will be delta 4 y. Fine. When you go up, energy is required. Here is 1, so here will be 0. When you go down, no energy is required, so this will be 0 as such. When you go up, energy is required, this will be minus 1. When you go down, this will be the same. When you go up, energy is required, this is minus 1. When you go down, this is same, minus 1. When you go up, it is minus 2. When you go down, it is minus 1, and something like that you will keep on going. Now we write the coefficients. First is 1. I'm going to write the coefficient. First is 1, then u minus 1 by 2. Next is u2, and u2 you know is u minus 1 by 2 factorial. Fine. Then it will be in between, insert u minus 1 by 2, because it is of degree 2. So now you will make it of degree 3 by inserting in between u minus 1 by 2. So u minus 1 by 2, u minus 1, I have inserted u minus 1 by 2 in between, and divided by it will be 3 factorial. Fine. Now next will be of degree 4, and it will be u plus 1. Here is u, it will be u plus 1 and subscript 4. And similarly, you know u plus 1 subscript 4 is equal to u plus 1 u minus 1 u minus 2 divided by 4 factorial. So this is the, and next coefficient will be, you will insert u minus 1 by 2 here and divided by 5 factorial, and next will be u plus 2 and it will be 6. Fine, and something like you will keep on going. Then this will be delta 5 y minus 2, and here you will write, if you want to write, you will be writing the next coefficient, and that will be here u, it will be u plus 1 u minus 1 by 2 and it will be u minus 1 u minus 2 and it will be divided by, it will be 5 factorial, and so on. It will something go like that, but we will be writing only up to 4. So from here I am going to write the Bessel formula. Yx is equal to mean, these are two terms, so mean of these y0 plus y1 by 2. This is only term, so this will be u minus 1 by 2 delta y0 plus these are two terms, mean will be taken u2. Okay, one time I will write u2. This will be delta square y minus 1 plus delta square y0 by 2. Fine. And this will be u minus 1 by 2 u minus 1 by 3 factorial. This will be delta cube y minus 1 plus u plus 1 4, and it will be the mean of delta 4 y minus 2 plus delta 4 y minus 1 by 2, and so on. You could write it in the open form. It is in the compact notation form, so you can write it in the expanded form. And what is that expanded form? This is the expression. Okay, done. Divided by 2 factorial. Find u minus 1 by 2 u minus 1 by 3 factorial delta cube y minus 1, and this will be u plus 1 u minus 1 u minus 2 by 4 factorial into delta 4 y minus 2 plus delta 4 y minus 1 divided by 2, and this will go on something like that. This is yx. So this is the Bessel formula that we have written from the table. Fine. So this we have written from the table. This is Bessel formula. So in this video lecture we have studied the Bessel formula, that is central difference formula, and have done its proof, and then we have this table, and from this table we have written the formula for direct use in the numerical problems. And we also got to know that this formula used when u is between minus 1 by 2 and 1 by 2, and more apt, more suitable when u is equal to 1 by 2. In that case, these odd differences, because 1 by 2 minus 1 by 2 will be 0, will become 0. So this is the Bessel formula. So that's all I have from this lecture, and I hope that you will be able to understand the lecture. Very soon I will be with you with my next video lecture. Till then, take care, bye bye, and see you soon. This is Dr. Rajesh saying you take care, bye bye.